Our planet Earth has a long and fascinating story. Imagine a giant storybook with pages filled with incredible events. Volcanoes erupt, shaping mountains and valleys. Oceans rise and fall, leaving their mark on the land. Life emerges in its simplest forms and evolves into the incredible diversity we see today. Get ready to embark on an incredible adventure. Join us as we delve into the depths of geological time, exploring the dramatic events that have shaped our planet and the life it supports. Imagine a giant layer cake, with each layer representing a different period in Earth's history. The oldest layers are at the bottom, while the youngest are at the top. This is the basic idea behind the geological time column. By studying the rocks and fossils within these different layers, scientists have been able to piece together an astonishingly detailed picture of Earth's long and eventful past. Each division represents a distinct chapter in Earth's history, marked by unique geological and biological events. Our journey begins billions of years in the past when Earth was a very different place. Imagine a fiery, molten planet constantly bombarded by asteroids. This is where our story begins, in the depths of deep time. We'll witness the formation of the first continents, the birth of the oceans, and the emergence of the very first life forms. So buckle up and prepare to be amazed as we delve into the fascinating and dynamic story of our planet Earth. Our journey begins in the Hadean Eon, a time of intense heat and chaos. Imagine a young Earth still glowing from its recent formation. The very air is a scorching inferno, filled with volcanic gases and the constant bombardment of asteroids and comets. The Hadean Eon, named after the Greek underworld, Hades, lasted from about 4.6 to 4 billion years ago. The Earth's surface was a molten sea of magma, constantly churning and erupting. As the Hadean Eon drew to a close, the Earth began to cool. The relentless bombardment from space gradually subsided, allowing the molten surface to solidify. From this fiery crucible, the first solid rocks began to form, laying the foundation for the continents that would one day arise. As the Earth cooled and stabilized, a new chapter began, the Archean Eon, spanning from 4 to 2.5 billion years ago. The name Archean comes from the Greek word for beginning or origin, and it was during this time that life, in its simplest forms, first emerged on our planet. It was in these primordial oceans, around hydrothermal vents, that the first life forms are thought to have emerged. These early life forms were single-celled organisms, similar to bacteria. They were incredibly simple, yet they possessed the remarkable ability to replicate and evolve. The Archean Eon, though seemingly alien to our modern eyes, was a time of profound significance, marking the dawn of life on Earth. The Proterozoic Eon, meaning earlier life, spanned from 2.5 billion to 541 million years ago. It was a time of dramatic change and innovation, a period that saw the Earth transformed from a world dominated by single-celled organisms to one teeming with more complex life forms. One of the most significant events of the Proterozoic Eon was the Great Oxidation Event, which began around 2.4 billion years ago. During this time, a new type of organism called cyanobacteria evolved the ability to photosynthesize. Oxygen, which had been scarce in the early atmosphere, began to accumulate, first in the oceans and then in the atmosphere. This had a profound impact on life on Earth. With the rise of oxygen, life on Earth was poised for a period of remarkable diversification and innovation, setting the stage for the emergence of the first multicellular organisms.
The Paleozoic era, a time of dramatic transformations and incredible biodiversity. It began with a bang, or rather, an explosion, the Cambrian explosion. Imagine a world suddenly teeming with life forms unlike anything seen before. The oceans became a kaleidoscope of bizarre and wonderful creatures. Trilobites, with their segmented bodies and multifaceted eyes, scuttled across the seabed. This remarkable diversification of life is recorded in the fossil record, most famously in the Burgess Shale in Canada. The Cambrian explosion laid the foundation for the incredible diversity of life that would follow. Life continued to flourish in the Ordovician period, 485 to 444 million years ago. The seas teemed with brachiopods, cephalopods, and the first true corals. But the Ordovician ended in catastrophe. A massive extinction event, possibly triggered by rapid climate change, wiped out nearly 85% of marine species. In the following Silurian period, 444 to 419 million years ago, the survivors of the Ordovician extinction diversified and evolved. Simple plants, like mosses and liverworts, established a foothold on the edges of continents, taking advantage of the sunlight and carbon dioxide that were abundant in the atmosphere. The Devonian period, 419 to 359 million years ago, is often called the Age of Fishes. Fish diversified into a dazzling array of forms, including armored placoderms, giant sea scorpions, and the first sharks. On land, plants were also making strides. Forests of giant ferns, horsetails, and club mosses covered the continents, creating habitats for the first terrestrial animals. The Carboniferous period, 359 to 299 million years ago, saw the rise of vast coal swamps. The Paleozoic era culminated in the Permian period, 299 to 252 million years ago. The continents collided to form the supercontinent Pangaea. The end of the Permian was marked by the largest mass extinction event in Earth's history, wiping out over 90% of marine species and 70% of terrestrial vertebrates.
The Mesozoic era. A new chapter in Earth's story unfolds, a time of incredible change, and the rise of some of the most iconic creatures to ever walk the Earth. Enter the Triassic period, spanning from 252 to 201 million years ago. On land, reptiles began their incredible ascent to dominance. Among them were the archosaurs, a diverse group that included the ancestors of dinosaurs, crocodiles, and pterosaurs. These early archosaurs were small and agile, well suited to the warm, dry climate of the Triassic. One group of archosaurs, the dinosauromorphs, possessed a key evolutionary advantage. They were bipedal, meaning they walked on two legs. This seemingly small adaptation would have enormous implications for the future of life on Earth.
And so we arrive at the Quaternary period, spanning from 2.6 million years ago to the present day, a period that has witnessed some of the most significant events in Earth's history. This era is marked by dramatic climate fluctuations, the rise of modern humans, and the dawn of civilization. It is a time of profound transformation, where the forces of nature and the ingenuity of humankind intersected in remarkable ways. The Quaternary is characterized by a series of glacial cycles or ice ages, during which vast ice sheets advanced and retreated across the northern hemisphere. These cycles were driven by changes in Earth's orbit and axial tilt, leading to periods of intense cold followed by warmer interglacial phases. These ice ages had a profound impact on life on Earth, shaping landscapes, driving extinctions, and influencing the course of human evolution. The advancing glaciers sculpted mountains, carved out valleys, and created the fertile plains that would later support human agriculture. It was during the early Quaternary that our own species, Homo sapiens, evolved in Africa. This period saw the emergence of our ancestors who developed tools, harnessed fire, and began to form complex social groups. We were not alone. Other human species, like Neanderthals and Denisovans, also roamed the Earth, their evolution shaped by the challenges of a changing world. These species adapted to diverse environments, from the frigid tundras of Europe to the dense forests of Asia. But Homo sapiens, with our large brains, complex social structures, and capacity for language and abstract thought, possessed a unique set of adaptations that would ultimately lead to our dominance. Our cognitive abilities allowed us to innovate, communicate, and collaborate in ways that no other species could. We migrated out of Africa, spreading across the globe, our ingenuity and adaptability allowing us to thrive in a wide range of environments. From the arid deserts of Australia to the icy expanses of Siberia, humans found ways to survive and prosper. We hunted, gathered, and eventually learned to farm, our impact on the planet growing with each passing millennium. The development of agriculture marked a turning point in human history, leading to the establishment of permanent settlements and the rise of civilizations. We developed art, music, and language, expressions of our unique cognitive abilities. These cultural innovations allowed us to share knowledge, express emotions, and build complex societies. The Quaternary period, this chapter in Earth's story, is still being written. The geological processes that began millions of years ago continue to shape our world, from the shifting of tectonic plates to the erosion of mountains. We are the inheritors of a long and extraordinary evolutionary legacy, shaped by billions of years of geological and biological change. Our species stands on the shoulders of countless generations of life that came before us, each contributing to the tapestry of existence. As we look back on this incredible journey, we gain a deeper appreciation for the interconnectedness of all life on Earth and the profound responsibility we have to protect our planet and its future. Our actions today will determine the legacy we leave for future generations, and it is up to us to ensure that this legacy is one of stewardship and sustainability.
Throughout our journey through the eons, eras, and periods, we've witnessed incredible changes in Earth's landscapes and the life it supports. But these changes haven't been mere background scenery. They've been driven by powerful geological forces, shaping the very stage upon which life's drama has unfolded. Imagine, if you will, the Earth's crust not as a solid, unyielding shell, but as a dynamic jigsaw puzzle with massive plates constantly shifting and interacting. These plates collide, pull apart, and grind past each other, their movements generating immense forces that ripple across the planet. These plate tectonics, as they are called, are responsible for the formation of mountain ranges, the opening and closing of oceans, and the eruption of volcanoes that spew molten rock and ash into the atmosphere. They are the architects of Earth's ever-changing surface. But Earth's dynamism goes beyond plate tectonics. The planet's climate too has undergone dramatic shifts over time, influenced by a complex interplay of factors, from volcanic activity to variations in Earth's orbit around the Sun. These climate fluctuations have played a crucial role in shaping the evolution of life, favoring some species while driving others to extinction. The geological events we've explored, volcanic eruptions, ice ages, asteroid impacts, might seem like distant events, echoes of a past long gone, but their legacy is etched into the very fabric of our planet, shaping the world we inhabit today. Consider the Himalayas, the world's highest mountain range, still rising as the Indian subcontinent continues its relentless northward push into Asia. Or the Ring of Fire, a zone of intense volcanic and earthquake activity that encircles the Pacific Ocean, a testament to the ongoing collision of tectonic plates. And what of the asteroid impact that wiped out the dinosaurs? It left behind a massive crater, now buried beneath the Yucatan Peninsula, a stark reminder of the destructive power of these celestial objects. But it also paved the way for the rise of mammals, our own lineage included, a testament to life's resilience and adaptability. The geological time column, our guide through this incredible journey, is not merely a record of the past. It's a key to understanding the present and anticipating the future. By studying Earth's history, we gain insights into the forces that have shaped our planet and the potential impacts of future geological events. We learn that change is constant, that Earth is a dynamic and ever-evolving system, and we gain a deeper appreciation for the interconnectedness of all life on this remarkable planet we call home. From the fiery chaos of Earth's birth to the rise of humankind, the geological time column stands as a testament to the immense power of time and change. It is a chronicle of our planet's extraordinary journey, a story told not in ink and paper, but in layers of rock, in the fossilized remains of ancient life, in the very contours of the continents. As we've journeyed through the eons, we've witnessed the birth of oceans and the rise of mountains, the flourishing of life and the devastation of mass extinctions. We've seen how geological forces, both gradual and cataclysmic, have shaped the Earth's surface and influenced the course of evolution. But the geological time column is not just a record of the past. It is a key to understanding the present and anticipating the future. By studying the Earth's history, we gain insights into the forces that shape our planet, the slow, relentless drift of continents, the explosive power of volcanoes, the cyclical advance and retreat of ice ages. We come to appreciate the interconnectedness of Earth's systems, how changes in climate, geology, and the biosphere are all intertwined. And with this understanding, we gain a deeper sense of responsibility for the future of our planet, recognizing that we too are now part of this grand ongoing story.